Good afternoon. Thanks everybody for joining this afternoon's session. Titled Identifying Data Patterns from Professional Practice. I'm going to introduce Van and then turn this over to him. Van Woods is the BIM Program Manager for the Seattle District of the U.S. Army Corps of Engineers. In addition to his 21 years with the Corps, Van currently serves as the Vice Chair on the Building Smart Alliance Board of Direction. He's passionate about bringing big picture ideas into production-ready environments through agile and proven software and lean production strategies. As technology advancements accelerate, he is interested in making sure that standards are relevant to practitioners and software providers, are fit for purpose, use best practices from internet standards development in other industries, and are able to be demonstrated and repeated through reference implementations. And most importantly, he wants to encourage a collaborative environment where all the best ideas and hard work can be brought together to accelerate improvements in the history as a whole. So that's the official intro. I'll give the unofficial intro. Did you write that? So what I was just going to say, I was trying to remember back. So I met Van about 3 years ago, I'm guessing, because I wrote a blog post about something about content, and I remember Van, I got this out of the blue from this guy from the Army Corps of Engineers. And I can't remember if it was the same day or that we set up a call, but I do remember it was on a Friday. I'm on the East Coast, he's on the West Coast in Seattle, here in Seattle. So we started about 5 o'clock, and I remember it was like 8:20. We were still on this long call, so it tells you that we kind of hit it off, had a good rapport.
Or I talk a lot.
Both. And then this kind of came about, I was here for the planning session back in February that we always do for the site visits, and Van was here, and he said, I've got this idea. We should be thinking about the schedule as the API to the building. And I'm like, you got my attention. So let's figure out what this thing, what we're talking about. So anyway, hopefully what Van's going to bring up today, this is kind of the start, I think, of what could be an interesting project, and I'm going to turn it over to Van.
Or just a bunch of crazy ideas, we'll see. Welcome, everybody. Thank you for coming to the session. Really appreciate it. These are my own individual crazy ideas, not of the Department of Defense. So, you could also call this, this very wordy title, you could also call it, how do you get started with data mining? Like there's a theory out there, there's some awesome plenary session, big picture, like, man, I'm fired up. And then I have to go back to my office and I'm like, I gotta fill in my timesheet. And I'm behind, and like, these parameters are messed up. So that's kind of what I do. I kind of try to bridge where we're at today to there. I want to start, though, with giving a huge special thanks. I wouldn't be up here, wouldn't have anything to even present or talk about. I've talked about this stuff informally with folks and kind of refined my ideas for a number of years. It wasn't until I really met Randall and I connected the dots with the Building Content Summit having, guess what, content and a recurring problem of taking an air handling unit and dropping it in your model and getting something scheduled. So that kind of got me thinking. And what we ended up producing together, and by together I mean you wrote it all, was this Revit schedule CSV parser that's up on GitHub. It's free and open source, and we'll talk about that today. So the second person is Sean Foster. Can you raise your hand? Mr. Foster, we joke in the Corps. We have a consortia of 90 members that we've been collaborating with for 10 years. And Sean was there from day one, and he is literally the mayor of BIM. Like if I need to know somebody or find out somebody or find out something that somebody is good at, that's where I start. And he's just been extremely supportive and helpful. In this presentation, we're going to be using some door schedules as an example of can we data mine door schedules. So he helped out tremendously with that. And his role is construction lead at Allegion, developing a very interesting product called Overture. So definitely ask him about that. I'm Van Woods. The only thing I'm not going to talk about myself, I just want to basically say that I span a lot of different perspectives. I have started as a research architect, fell in love in '98 with theory and research and design science and all this like really heady stuff. And then I got thrown in the production timeline and I'm like, none of that, like nothing works. Everything's broken. It's just such a huge disconnect. And I've kind of worked my way up to BIM program management and also vice chair of board of direction of Billy Smart Alliance. So I've come at it from a lot of different perspectives. So the session description today basically would say that, you know, the premise is, can we do automated mass data extraction analysis? Is that achievable today? We talk about it, and can we do it with quality? The other thing is, that we'll talk about is how you guys can pick this free tool up and start contributing towards a data-wide industry movement, if that's of interest. I figure I'm going to try to tie it to BCS and problems we're talking about, because this is what's relevant to what we're trying to do. So essentially, we're trying to harvest data. One differentiator, there's going to be a bazillion ways to get data out. I need quality control data that I can get out at scale, quickly, large number of files without spending more time doing checks on the data than actually extracting the data and analyzing the data as well. So my big picture goal is that this would be stage one. BCS 2019, proof of concept, pitch it to you guys, let you see what, get some feedback, see if anything resonates with folks, incorporate some feedback and changes. And one thing that Randall said, I wanted to basically reiterate that I believe, if anybody is interested, that this is one way that we can, by BCS 2020, when I leave today, is the beginning of day one, and my deadline is BCS 2020. Can we do something between now and then that's practical, that can actually help at least provide some insight? Maybe it's not we're going to solve all the world's problems, but what can we do with data that will help us answer some building content questions? So, basic outline. I will just paint a picture. This is basically going from 10,000 feet into the weeds. So if you only care about the weeds, you can sleep through this. If you aren't an in the weeds person, you can sleep through both of them. A lot of this has already been talked about in terms of the rise of artificial intelligence and data science. It's a hugely popular buzzword. We have many examples of generative design, evolutionary algorithms. This whole conference is smack dab full of the top 1% people who are exploring this concept. And it's not a new concept. This has been, there's been a lot of discussion about this since the 60s. So this is a really good resource if you guys want to read up more on what's out there. I started looking at this type of problem back in 1998. You'd think I would have got something done by now, I would think. But what I was actually looking at was more of the precursor to today's dynamo, let's say. Some of the early discussions on that. So what is still relevant to our discussion here is that if you were able to hear Phil Bernstein's presentation, in the design theory world, this wicked and tame domains, it's highly complex environment, but if we have bite-sized problem spaces, we can actually make some progress towards implementing these ideas. This kind of stuff is really getting into mainstream. Maybe not mainstream, but I should say it's becoming out of any of just the research environment. They're not just researchers playing around with this stuff now. Although he is at Harvard, so not necessarily a practitioner, but there's plenty of examples. If we take HiPAR in the back, there is, I'm going to call out Mr. Hawk here and just say that there are a lot of very interesting pieces of work that are becoming available that are going to start making these concepts real and available and not out of reach. And so this is a great article that just kind of, like, if you're struggling to connect the dots between what does this, I mean, that's cool, and we can just sit there in awe of like, wow, look at that, that's neat. And then go back to work. I did that for a while, you know. They outline in the article some really good examples of the application of artificial intelligence, machine learning. The number one thing, just to go back, all AI eats data for lunch. If it doesn't have data, it starves. There's nothing for it to do. And if I start looking out on the joyous interwebs and I start saying, well, surely there must be some data out there that we can crunch on. I'm going to go to BCS, let me go get some data sets. Well, okay, there's this one, some 5,000 floor plan images. I'm like, well, that's not going to help me with parameter data. But, wow, that's pretty cool. Ooh, so this person had done some very interesting, identified certain features, a lot of computer vision type stuff, and then visualization, and then floor plan reconstruction from photos, and those types of things. But where's the beef? Where's the meat? Where's the data? Where's the tofu? So here's another example, and another. All very fascinating, but basically, I feel like we're at the beginning of, I have flashbacks to the beginning of BIM where I could be talking to people and I could tell right away that they were like, that's interesting, but it doesn't really pertain to me. You know, and I'm like, well, if it doesn't pertain to you, like BIM is, that whole argument of you are working with data and BIM and all that. We're getting the same thing with machine learning and with data science and analytics. Is we're interested, we see a lot of cool examples. This is an interesting time because what we don't realize is we are sitting on the most valuable resource in this movement. We are the subject matter experts in the building industry, period. Any of those other examples that we look at, when you start digging anywhere, they start to get a little cartoonish. And it's because we are the ones that are working on the real world case problems. So don't discount what it is you bring to the table in this world. You may not see yet where it pertains, but the oil, again, of the new industry is data. So, what types of data? I went harvesting for data in the core and really found a whole lot of stuff. I'm like, I got a whole bunch of PDF, and I kind of started to say, well, where's the largest source of data that I can harvest? And I'll talk about my organization a little bit in a minute. But this is just kind of like some high-level stuff. I mean, BIM and Kobe were way down at the bottom. I mean, I've got 100 years of PDFs. Got a whole ton of CAD stuff. So degrees of semantics, like raster versus vector equivalent is like some of this stuff is, it might be vector, but in data sense, there's no data schema, there's no database, there's no, it has info that can be data mined. So there's high density data, low density data, high volume of data, low volume of data. So there's actually quite a bit of data floating around. Lots of data sets, hardly any of them are published in public from BIM. There's no data scientists in academia coming up with really fancy ways to solve your problems. And what we've traditionally talked about in the AEC and BIM community is standardization, interoperability, lifecycle data exchange, things that make me have gray hair. It's really tough. It's hard stuff. We're working as hard as we can to try and define data standards. And I think, or not just data standards, but having us get the I in BIM. If I hear that one more time, I might absolutely croak. Okay, we get it. We need the I. What have we done to, like, how is it getting better? And so I think what's interesting is just to say, if we can expand the discussion to say, well, how can data science help our problems? That's what I challenge you, is to say, BCS, how can data help us inform our data standards? That's just one problem, maybe. You answer the question. I'm not going to answer the question for you, but data can help. Maybe a little bit. Maybe it's not going to answer all your problems. Most of the thorny problems are process and people and the environment, but at least us as advocates of data, we should at least use data to help us solve some of these data problems. Just saying. So there's a lot of really cool info out there if you want to kind of ramp up. And one of the quotes I really liked was "Everything is data" from Mr. Fano. And depending on what the problem is you're trying to solve, maybe a count of files tells you that. It really was breaking down the walls of us thinking about I in BIM as Revit DB link. So just a couple slides that I gave at the University of Washington, just to say, I started down this road and I was like, ooh, I heard this like bias in data stuff, and I'm like, well, I'm not sexist, and I'm not going to think that I have some sort of social biases. That's what bias is. It's bias in data? No, definitely not me. And I was like, oh, wait a minute. That's just that pile of category of biases. It's fascinating. If you start looking at, it's just on Wikipedia. Just go check it out. We imagine things and people we're familiar with or fond of as better. We simplify probabilities and numbers and make them easier to think about. I mean, all of these things that data scientists have already, through hundreds of thousands of academic years and application of data science in so many different areas, they even have a list already of 193 possible problems you could incorrectly think about data. So just don't do it, or at least be aware that you could do it, because it's really interesting when you start getting into data science and you start to say, okay, I'm sold, it's cool, I like it, I want to use data to solve problems, and this is like a classic data science 101 probably example case of where data science could have gone completely wrong. And I'm not going to go into depth about this, but I really I'd love for you to go check it out, because what's just interesting is technology is an amplifier. We know that. We know that with BIM. We've been saying that you can either be amplifier for good or for bad. When we start to make decisions with data, we have more confidence in it, sometimes falsely, without knowing that we actually made exactly the wrong conclusion. And this is one of the coolest examples. So, another kind of point that I get into a lot of discussion with folks is like, all right, that's cool, artificial intelligence, again, cool, exciting, but what's the problem, Van? Like, are you not familiar with this thing called Dynamo? Or Vitso, or Minecart, or Auto Minecart, or FME Safe Software, Solibri, Codebook, Unified Plugin, Avail Stream, CTC BIM Data Suite, Flux, not anymore, Speckleworks, BIMRX. I mean, it goes on and on and on and on. There is no shortage of ways to get data in and out of BIM. Totally agree with that. There are some examples, Lunchbox for ML is pretty interesting. Problem is, garbage in, garbage out. It doesn't matter that we can get a whole crap load of data out if we don't know what the quality of that data is. And since I'm in Seattle, I use a very environmental kind of analogy to say, data doesn't kind of compost. Doesn't get, you don't put it in the different, there's 6 different trash can types. You don't put it in the compost bin. It gets better. You just let it stew for a while, and then it comes out as nice black soil. No, there's, sorry. But I even think it's more complicated than that. I really think that a lot of data quality challenges that we talk about all the time in our production world of plan, set generation, and all this, when we are doing projects, most of the complexity, I believe, comes from the environment. It's really complicated. This complicates things. Legal complicates it so much, I put it in its own category. And quality, depending on, so data mining, a basic principle is, if you spend more time cleaning the stuff you extracted, then that's low value. If you can find ways to extract at scale huge amounts of data in an automated way that you know for sure is at least already been quality controlled in some form, it's a much higher level of confidence. So, the first bullet of complexity is breadth and depth. And the Corps of Engineers is a 35,000 person organization. We do in-house design. We contract for designs to be delivered. We pay for construction. We do construction administration. And we're the owner's rep for any federal agency that wants to have a building or civil works structure built, or anything that they want to pay us for. We'll take their money. It's great. We operate here in town if you have time. I know this is a conference and you never get to see outside. If you go to the Ballard Locks, that's one of our operating projects. So we are also an owner-operator of civil work structures. We also have a research lab that develops things like Kobe. Sorry, it's a cough. We produce data in-house. We procure it. We try to expand the space, and we use it as a life cycle. So I couldn't make it any more. I'm not just a design firm, you know, or I'm not just procuring data, or fortunately or unfortunately, our organization kind of covers the gamut. So what's good is I have access to in-house designers and their work products. I have access to every one of you or anybody in the private sector who has submitted a project to the Corps. Is public domain data that I can take a look at, and that's a huge volume of data. It's not my data I'm interested in. I'm interested in an industry-wide cross-section so that we don't have selection bias. So, but I do have a lot of data to develop a process that maybe everybody here can repeat. So, we also, I also wish it was just BIM that I dealt with, because then I could just be like, all right, I've got some BIM data I got to analyze, and I can focus. Good or bad, we are desperately working to integrate BIM, SIM, and GIS in all aspects. As long as it's a vector, and it's data related to that vector, and that vector represents something in the built industry, dang it, we've got it's in my wheelhouse. It's good. It's just challenging. Multidiscipline. Survey, geotech, civil, landscape, structural, architecture, interiors, fire protection. This is all in-house disciplines, by the way. So, fun. Good times. And this is what life looks like when I try to buy a BIM, when I try to procure BIM as part of a construction design and construction project. And this is, if you really need some nighttime sleeping material to fall asleep to, this will do it like real quick. This is really complex process stuff. It's not easy. We have this is the owner swim lane, this is the private sector swim lane. We as an owner, this is the bounds of a project. We have to, as an organization, develop templates for BIM contract language, project execution plans, minimum modeling matrix. Some of you may have been subjected to these already, I don't know. We issue them in a project and it goes through cycle. This is the really tough part, is the quality control checking. So we have a toolbox. In that toolbox, there's all kinds of stuff to help us ensure that you understand what we need and we can have a dialogue up front about what's needed, that we can run some tests to make sure that we're on the same page. This is 10 years of development, essentially, of trying to help us get repeatable results when we go procure models. So, after 10 years, I must have got all that data must be like perfect, right? I must just be able to extract all the data out of all the BIMs because it's gone through all that complex process. I'll leave that as a rhetorical question right there. So now I'm going to go, that's kind of second bullet on complexity. It's like, we get it, it's complex. Well, this was an in-house example that I thought was maybe more tangible, kind of something you can relate to. We did a pretty extensive QTO data standardization effort internally. And you know, we had cost engineers and designers working together, and we had a process, like what do you need, what can you give me, you know, all of this kind of negotiation. And you know, for this column, so this is the cost engineer kind of talking about walking the management through like this process of what's the problem and what can BIM help us with quantification. So they identified that for that footer, for that column footer, some data was in the schedule, some was in the construction notes, but not everywhere. And then he's like, check it out, here it is, 2000 PSF, reinforcing bar, thickness, boom. It's like, awesome, except it's wrong. It's like, And I've been through 3 major quantity takeoff initiatives in the Corps, and it always goes this way. So there's a ton of stuff. It's like, mind-blowing, amazing, why are we not using it? Keep fast forward, it's like, oh my gosh, there's too much stuff, none of it's right, what do we do? So, here was the conclusion, was that actually the family name may not have actually been the best place to get the pounds per square foot. I'm like, I could have told you that. But what did he know? He opens up Navis, he's like, it's there. It's like, okay, well, I did this is, I tried to find one that was your Chrome example, couldn't find it. But he used photometric web file. I don't even know what that is. He probably didn't even look at this. He's probably like, these things that I'm counting are probably recessed. That's the flag right there. So, you know, I had to go through a whole process of explaining to him that recessed 2x2 LED was just a delivered piece of stuff that, he's like, what's wrong with you BIM people? There's just garbage everywhere. I'm like, no, it's just complicated. And so, I sat down after many failed attempts of trying to explain to this person that we have system parameters, okay? We've got shared parameters, we've got project parameters, we've got family, we've got materials, okay? We start with templates and we do a project, and in the projects there's sheets and views, and there's families and instances of those families, and some of these parameters start here, and like, he's like, you guys are just, what? This is crazy. He's like, I just want to know if this data is right. And I want to know where to go get it. Other way around. He wanted to know where to go get it and if it was right or not, or how we would make it right. So I did what any good BIM manager person would do, and we got to define standards. Well, we got to make sure that the authoring people know where to put the data so that the consumers, when the data comes out, and then I'm going to sit in the middle and we'll have checkers and life is good. And then, so we're still ongoing with that. That still needs to happen. That, design authoring needs to know what needs to be done, how it needs to be done, and we need to know how to extract it and consume it. And then after going through that whole explanation of saying there's certain things that users can't change, like system parameters, and they're calculated on the fly, and math is pretty solid, okay? There's also like standard libraries, which for the most part, spot on. Until I did an example with Solibri, and I was like, okay, I'm like, what's the most standardized thing I can think of in the industry? I'm like, some steel. All right, so let's go get the AISC steel list. Boom. There may be some content in certain products from companies that start with the letter A that have content that don't match industry standards. So even things that he was like, this should be like no-brainer right. And I had convinced him it was no-brainer right. And then I checked it, and I was wrong. It was more right. And so this was the conclusion. He wanted a minimum viable product. He didn't want more data. He wanted less data that was 100% correct and 100% guaranteed to be delivered. He'd be happy to do everything he did before and just get a couple more parameters that would simplify his life, because the regulations in cost engineering put him at risk, and he would take on liability. So we went through this whole rigmarole and kind of had a big discussion about the importance of drawings as already being in our quality control process. Forget BIM, just in our architects and engineers' workflows, we quality control those sheets. So there's tons of data, very little of it. I have data trust issues. Big time. So the other thing to ask is, that family name that was wrong, was it wrong that it was wrong? How wrong is that? Like, should it have been right? Should it have been trustworthy? So here comes the law. Usually when I get far enough down in a discussion with folks and we're having issues and problems, it's like, okay, we got to go back to the contract. Contract is the determination for right and wrong within the context of a project. So, basically, in summary, there's no shortage of ways to extract data. Very difficult to determine the data that you wholesale get out of there. Is it intentionally, does it represent the design intent? Or did it just come along for the ride? There's very little to no right of reliance of that content. In the sense also that legally and from just a pure quality control process, we're trying, we're improving. I'm not saying we shouldn't, but just generally speaking, drawing schedules, you don't go to jail because that family name was wrong. You go to jail, or you get sued, or you have to at least answer to somebody if that door schedule was wrong. It's like, okay. Now, drawing schedules aren't the solution to everything. Drawings aren't the solution to the whole data problem, but schedules are a big chunk of existing tabular data. So, standards, this is for, is there anybody in the audience that isn't in the building industry? You're like a data sciences specifically person? Just data science purely. Never dabbled in not a single one. That's a problem too. So I don't need to tell you guys what schedules are. You may not know that the National CAD standard has standard schedules that no one's ever used. But there's some. So there's some basis for what some experts got together and thought should be in a door schedule. Some examples. And, you know, we can crosswalk. One of the premises of COBE and in the COBE guide is that the design schedule has data that appears that is mapped to COBE. So, in a nutshell, we have databases, and they're generating schedules, at least 85% of the time. There's still drafted schedules that we get when we quality control our submittals. But it's getting better every year, and it's pretty solid. And, you know, it's not just one database, it's interconnected, linked databases. And by databases, I mean like, for example, a Revit file. Okay, so Revit files being containers of data that are connected to each other that generate that. If you're, you know, kind of with it, you're moving in the future. It's some of that data is in the cloud, some might be out of the cloud. I can tell you one organization that I'm assuming will be data mining your data, which is when you put all your data in there, they have quite a large aggregation of building industry data that they can data mine. But no matter where the data sits, there's the relationship between the data and the drawings. And essentially, I can boil it down to this, that when you start to hear words such as legally binding, right of reliance, that there is an order of precedence, all of these things refer to the basic environment that we deal with for executing projects. There's a contract which references construction specs and documents. If there are discrepancies between these three, contract wins, and it will state that specs trump the documents if there's discrepancy between the two, or the contract can say whatever it wants. It can say the opposite. But I'm just saying, generally speaking, these are the three pieces that establish accountability. I don't care if you're talking IPD, I don't care if you're talking, it does not matter what your contract vehicle or mechanism is, there always has to be some agreement that establishes accountability. You may shift, it might be shared responsibility and shared pain, you know, but no matter what, there's a description of what is required. So if we go back, unfortunately, while I, as a BIM manager and a BIM program manager, may want to get upset with my designer for the 2,000 square foot PSF USACE footing family, which was actually a 3,500 PSF concrete footing, but he didn't care what the name is. It's the same shape, plop it down, done. I'm like, you are wrong. He's like, and I'm busy. So, that's the boiled down version. And the terminology is that this is legally required and the right of reliance is on the sheets. This is reference material that produces that. There's only one customer that I'm aware of that we service, which is the Veterans Affairs, and you guys can look at their BIM manual. They're the only ones that are starting to say for more than 10 million that maybe some of those ideas might be different. But certainly, that's one customer out of hundreds. We are, the adoption curve, the innovators, like, I can only point to one. There's other examples of right of reliance on the model in the private sector, but we're definitely not, there's not data that we can legally rely on in high volume. So don't we, well, I'm skipping ahead here. again, in summary, drawings are a good filter to identify data that has already been quality controlled and is legally required to be right. Schedules are one place to find a lot of data on the sheet. And my question is, can we extract schedules from 50,000 files? I mean, 100 files? And I mean this group specifically, I don't mean abstractly. Can we extract 500 files? And don't we want to have, just to step back a little bit, don't we want to have the right of reliance on the model? Yes. That's not the topic of this presentation. It's not the topic that I'm promoting and pushing in this discussion. What I'm trying to do is to find high volumes of reliable data that I don't have to spend more time cleaning than extracting. So, different presentations you can go to on the right of reliance, and hugely important. This will move our industry hugely. Isn't the future no drawings at all? Like what, Van, it's like drawings, that's really sexy. Drawings. You've heard this like 3D and BIM and all this. Yes, I get it. So I'm a little impatient. I want large volumes of data today because we've kind of been talking about some of these things for a long time. So we are now officially in the technical weeds. I will walk you through 3 different examples. One is I had to start with a project of inventorying and cataloging and organizing 1 million files. And that was really fun. So I had to do an inventory of a whole bunch of stuff, and I'll share with you ways that you can scan your network for free and for easily out of tools that you already have available. This is kind of the biggie, the extracting the schedule data from BIM, and an example of spec data. So on this, just briefly, again, there are many ways to get data out of BIM, even schedule data. I needed it to be free and open source in order for it to be crowdsource friendly, to get as many people on the bus. These were the kinds of conditions that I myself, cloud, if I had to cloud process it, done. No, that's not going to happen. So I also didn't want to have to train people because you lose them. So step 1, go find all of the Revit files in your organization. There's 100 ways to do that. It's not that hard. It's just one way. What's unique about, I used a PowerShell script. You type this string into your command line, spits out a CSV file that has a list of all the files, file names, directories, last access time. It's kind of interesting to me. So there's a lot of just abandoned, dead garbage, but a timestamp didn't necessarily help tell me that. Somebody may have just, recently modified files, but the ability to not even open a file and find things that people were actively accessing, even if they didn't modify it, was interesting to me. So I kind of fell off the data deep end. I'm like, this is a horrible exercise I have to go through, so better get some data to help me with this. Also, did an MD5 hash out of this, and what that just basically means is it's a unique identifier that regardless of the name of the file, the contents of the file have a unique identifier, and so you can find duplicates across an entire network regardless of timestamp, file name, whatever. And with about 1 million files, ran this overnight and came back and I had a database. And Power BI example would show you that from the 90s to today, for PDFs, DGNs, RVTs, and DWGs, over time, you can see Revit use was pretty much non-existent prior to 2010, then spiked, and year after year has kind of continued. DGNs, we have a long history of MicroStation and Bentley products, so we can kind of see the trend on that, and DWGs, and PDFs still still up there. And this is just really simple. This is like, and this is how I learned Power BI, and it took me some time, and it was a good practical example for me to sink my teeth into. So in this example, it's I'm comparing counts versus file size. So I have more DGNs, and why do I have so many BNP files? Number two, I got something is messed up. I got to go look into that. I haven't had time, but for the life of me, cannot explain that one. Was not expecting that. CAL's files are like the precursor to PDFs, and so anyway, that's count of files, and then just by file size, hands down, PDF, DGN, RVT. So even though I only have 2,400 RVT files, it's not that far off file size-wise from PDFs. So, this is the utility that Donovan wrote of Avail, and we worked on it together, and it's been published on GitHub. You can go here, you can download this RVT, and you can also, there's test data, there's a gig or so of Revit files that are the Medical Center of Expertise published room data sheets. So we've got about, I think, a gig or two, I can't remember how much, but a lot, enough, 88 files that you could replicate this process, even if you don't want to do it on your own files. Don't trust me, I wouldn't trust me. Do it on the test files. Okay, this is all out there, available. It will identify whether a particular schedule appears on a sheet. That's another differentiator. There's a lot of schedules in a drawing, or in a model. A lot of them are COBE utilities or internal working schedules for QCing data in the model. This was a kind of this was a game changer, especially for the thesis of my whole argument that if it's on the sheet, it's been quality controlled. So thanks for getting that one working, Jonathan. Because first version, we were like, I got all the schedule data out. I'm like, I cannot get away from these COBE schedules. There's more COBE schedules. It's not on the sheet. I'm like, but he figured it out, so that's good. So the basic, just walk you through it quickly. Step one, collect a lot of Revit files. If you have Revit files, if you're in a design firm and you have access to maybe 100, 200, 500 Revit files. Good to e-transmit when you bulk process anything. I don't care what you're doing. You can screw up a lot of stuff really quick. I'm not saying this will do that, but I've never, ever batch processed anything on live production data, ever, ever. So e-transmit it all out. All of this actually takes longer than the extraction itself, which is crazy. I had to convert thousands of files to one format just so I could scan them all. That took a heck of a lot more than the actual extraction process. So I started to go through, you're just smiling and laughing because you're like, you told me, you're like, if it's not, it's going to take longer if it has to upgrade each file. I had one file that had many links across them and it would not retain on a batch upgrade. It just reads in all of the links and upgrades all of them. And if there are 4 links, it upgrades the first file and all the 4 links. It opens up the second file. Having not upgraded it, it upgrades it in memory, and then it goes and upgrades all the other 4. And so you, you end up, just trust me, get them all in the same format. And then you have to hit enable macros. You'll notice this is just an RVT file that starts up and runs a macro that's embedded in it. And it auto starts and asks, do you want to run this parser exporter? You select the folder that has your files. It identifies, in this case, the test data set has 88 project files. Where do you want the output to go? Where's the CSV? Where's the data that it crunches out of the schedules come from? It chews through all 88 and boom, you're done. It took 9 minutes to do the 1.18 gig. Ended up with 7,200 columns of data, an average of about 7 schedules per Revit file. I was assuming and estimating that if I were to get 1,500 files with 10,000 schedules, it'd probably take 2 hours to mine them all, which is tremendously good. It's fast. And the other thing that's good is I did very little to no post-processing of what was extracted. I was able to go straight from extraction into analysis. Export to CSV file. Lowest common denominator when you start getting in the data science world. CSVs are, that's like the lowest, simplest. There's no barriers to entry. There's no database. There's no JSON. There's no complexity. Anybody here, I don't care if you've done any programming in your entire life, ever, you can understand and open this and maybe delete things you don't want other people to see, or check if the extraction came out right, whatever. CSV is very accessible. Found this one out by accident, that actually schedules have carriage returns in the schedule themselves. Foiled again, but Donovan got that case covered. I think there are a few other cases that are still probably going to foil it up when you batch process anything. It's amazing what you find. So I wouldn't be surprised if we find something that might give it issues. But when I ran it across the ton of files that I did, it's pretty solid. And up on GitHub is kind of the definition of the schema for the programmer, data scientist, data nerd types, for them to understand what the heck this CSV represents. And so the CSV is generally speaking a very basic way to represent a schedule in a comma delimited file. So schedule, here's the file name, schedule title, BRAR equipment schedule. So that would equate to this column in this standard schedule example. This is door and frame schedule. Under column headers and column values, this is a column header. These are stacked, so they're separated by pipe symbols. So under door is mark. And so this column, the column header is door, pipe, mark. And the values are 1, 2, 3. And that's the basic format. Easy peasy. There's a second repository. So this is a platform-specific data extraction tool for Revit. There's literally no reason. Somebody needs to put me in contact with other platform folks, ArchiCAD, and it doesn't matter. The extraction format only is about a schedule. So it doesn't really care what the authoring tool is. Anybody can write out to this format. There's a second repository which is just for submitting data samples for people to analyze. All right, third example is the whole building design guide, which is the in the government arena. We basically have multiple agencies that came together to find the commonalities between their construction specs. So this is our guide specs that the Corps of Engineers, NAVFAC, Air Force, and NASA collaborate on. It is a public domain, 21,700 page long set of guide specs. It's like, wow, how can anybody get any project done ever? That's amazing to me. I'm like 21,000 of standard spec language. Obviously that gets pared down for what a specific project needs, but holy moly, it kind of was pretty amazing. It's also a specs intact file, which basically means that it's not only a PDF of the guide specs that all these agencies use, but it's also tagged kind of like an HTML, just you'll see on the next page. But here's a very simple data science question. I will give anybody an imaginary prize because I cannot give you a prize, but I can give you a pat on the back. You can tell me how many times the word BIM appears in our spec. 0? No, don't guess. You have to tell me, no, I'll tell you it's not 0. It's more than 0. I'm not asking for you to tell me now. If you want an imaginary challenge with an imaginary prize, you could check 21,000 pages to see what these agencies, how many times they reference the word BIM. And this is what it looks like. You can see the little tags in here that kind of, this is valuable stuff to data science folks because it's already kind of been identified what the text means. So, what kinds of questions can we ask of this type of data that we extract? This is a big one to me. I mean, you guys have your own things that you may want your data to help inform you on, but I'm very interested in knowing, are we getting standards to help with the top 5% of the top 5 parameters for all families to simplify it for content producers and distributors to reach and provide data that applies the most benefit to the most people. And I don't have any numbers. I don't have any, we just had this discussion yesterday. We had the panel with the 4, we just went back and forth talking past each other not past each other, but there's debates about, well, what do you need, and you want too much, and you're asking, you know, the whole what parameters are included. Well, has anybody looked at any data? Can we just start there? Like, what are the top 10 schedules, and what are the top 3 things that are on those schedules? And if all manufacturers could provide just those 3, so you could take the content, put it in your project, the schedules, we'd be in a better place than we are today. So minimum viable product is, you know, a very important approach to dealing with highly complex environments, and it's helpful to know what the most useful, minimally common set of things that we already use. Not that we think we need, not that we hire experts to tell us this is our expert opinion. Your last 20 projects or 200 projects will already tell you what you put on your door schedule all the time. Statistically speaking, whether you have a good BIM manager, no BIM manager, whether you do BIM at all of that, it'll tell you. My point is, until we start having some data, I'm really kind of tired of talking about data standards. It's just really exhausting. The first 10 times, I was like, I'm not going to give up on it, keep trying. I started getting gray hairs, having kids, I'm like, it's exhausting. So maybe I'm just lazy. So, I figure maybe a different approach to some of the problems maybe that BCS has been encountering, maybe not. This was, I think, some of the things we were brainstorming is that, you know, can we use data to inform our data standards? Can it help solve some problems? Can we get 10,000 door schedules first of all? And if we did, what would that tell us? Yep. So there are many ways to get into using this data. I'd encourage you to look at some of the business intelligence platforms like Power BI and Google Data Studio, which are free. And readily available, but even if you don't do that, spreadsheets can get you pretty far at telling you quite a bit. So this is an example that we worked out with Randall and Donovan and myself using Google Data Studio. I extracted 162 files, had 4,600 schedules, of which 1,200 appeared on sheets, and there were 69 types of schedules, over 14 disciplines. You could see that drawing list came out as most common. Oh my God, makes sense. That's kind of, thank God it didn't say something totally random. You know, it's like, at least that conceptually made sense to me. I'm like, okay. And then second was door, room, keynotes, room finish. And then the ones that are just on the sheet itself, door came out. Door trumped drawing list. I'm like, that's interesting. So, cool thing about dashboardy stuff is you start, you know, it starts becoming interactive, and you say, okay, well, here are all the disciplines on the left side, and then total count across all disciplines, door, drawing list, room. These are schedules that appear on sheets, mind you. It's biased on door because I knew I wanted to have a presentation about something, some type of object, like a door, and so I threw a bunch of architectural schedules at it, so this is a lot biased towards that. So this, you know, structural is very concise. Start to dig into the parameters. Started to look at parameters by type of schedule and type of object. Fire rating, my favorite headache example. We'll come to that in just a minute. Door schedule, door types show a very consistent pattern of use, whether you even schedule, you specify them or not. Designers are using standard terminology to identify door types, and that's because there's actually a standard, SDI 106, and if we look at the steel Door Institute, they've got some standard nomenclatures. Great, there's a standard, it shows up in the model. So, those are some very basic BI kind of tools of looking at data and trying to learn things. Sean and Allegion helped with some little more complex machine learning examples. So, hierarchical agglomerative clustering means something to a data scientist, and you can Google it and Wikipedia it and check it out. What it basically can tell us is that in all the door schedules that were taken, it was able to identify 1, 2, 3, 4 basic chunks of types of values, and they meant the same thing expressed different ways. 1 hour, 1 HR, 80, 60. You know, these are all one way of expressing it, and we didn't tell it any of it. This is how it chewed up the data, and then this is the garbage category. Do not use NR. That's wrong. That's actually a valid fire rating. Is not rated. So you still got to look at these things, but it was a proof of concept to say, let's see what machine learning can tell us out of 4,000 schedules. And if you want to get started today for free without having to become a data science expert, there's this awesome platform called Google Colab. And what it does is it sets up a virtual machine for you with a GPU, and you can use TensorFlow if you're so inspired, and go jump in the deep end of the pool. You'll jump back out and say, oh my God, I can't believe I just did that. What was I thinking? But at least there's no barrier to entry. And they got a lot of really cool examples. So I was able to create a word cloud. It's really highly sophisticated machine learning. I was able to prove that I could connect to the data source and get some input and output. And then I called Sean and said, Sean, I need some help, man. I can't get it. So this is kind of wrapping up some ideas of how you've listened to me long enough. I appreciate going through all of this. There are different things that you could do if you're so interested, and I would highly recommend reaching out to myself or Randall, and let's talk. Because some forward-thinking folks will be the first out of the gate. And I mean at the practitioner level, not at the 1% high-end design firm that has data scientists on board. I mean the early majority, the 14%. So let's give it a shot if you're interested. And since I like data, like to get your feedback for this session, good, bad, or ugly. Give me your honest feedback. And I had to actually, since I had never done this for the other speakers, I'm like, I better figure out how you actually do this. So there you go. Session materials there. And are there any questions? Thank you for sitting through that.
Hi, I wanted to ask about the whole Revit upgrade process.
Yeah.
I can see how that can be a really daunting task.
Yep.
I was going to ask, did you consider maybe, when I was talking to some folks from Building Smart, they were basically suggesting the IFC format,
Mm-hmm.
so format as a way to store your data on the long term, basically. So have you maybe tried to explore that path and decided against it, or you just kind of went straight for Revit? And is the consideration for the future?
Yeah, the point, yes. Short answer is yes, I considered IFC. I considered all those other tools that I kind of rattled off very quickly. The differentiator was I needed to know that it was on a sheet. IFC doesn't really care about sheets. Didn't have any signal identifier to say that that was on a door schedule. Doesn't mean we couldn't figure out door type, door mark, all those type, fire rating. There are IFC attributes for all those things. I don't have time to go map all the IFC to things that typically appear on schedules, and it's a chicken and egg problem. I don't even know what are on the schedules. I just need to get all the scheduled data out in order to formulate some patterns and find some info. You know, their bulk IFC export, it's pretty hard. Bulk consistent IFC export. So there's more data than what's on sheets by far. So IFC is a fantastic container for a whole lot of stuff. I'm not discouraging that at all. I'm on the Building Smart Alliance Board of Direction, Vice Chair. I should be fired if I said you shouldn't. You should at least try.
You mentioned about looking at, I think it's 21,000 page document.
Yes.
Specifications, right?
Yes.
And then putting that into extracting that data.
Yes.
Have you ever done it with like building code analysis documents?
No, I have not, but natural language processing machine learning work that chews through similarity analysis based on word segment locations, things that appear next to it. There's a lot of like bulk machine learning processing that can be done. I think that's a great example.
What was it called again? Sorry.
NLP, natural language processing. So that's basically like free-form text.
Yep.
Like you can put a research paper in there and it can tell you what's the subject of it based on the frequency of word patterns, and there's all kinds of really cool stuff that I haven't even started. I need to go into Google Colab. I only started touching the surface of analyzing the schedules, but I recognized that was the specs were a readily available large volume of tagged and identified data. So I want to stimulate the conversation, but I think that's another very, very good source. Great idea.
Question?
out of all this work that you did, I guess I'm wondering what is your what are you taking back to your bosses and telling them, oh, this informed me that we should do this? What lesson learned did you are you taking back from all this? It seems to be all still big picture, so I'm not sure.
I understand. Part of it is extremely big picture, and for Revit modeling and BIM manager activities type of thing. Maybe this can help you with quality assuring your schedules quickly without having to open every Revit file. You could just get all the schedules out and see if it changed from the last submittal, 35, 65, schematic design development. So my use of this internally is premised on the fact that the whole industry kind of has to get their hands around it. It's just bigger picture than my in-house production. So we are in a content management exercise, so I intend to use it for that. How many doors do we have and what data is on it? There's more data that's on schedule, so I'm not saying that's the best use of schedule-related data, but it's important data, so you could use it for that, content management type stuff.
Anyone last question?
All
of
them. Do you see? You mentioned the VA has they're changing their contract language for over 10 million.
Mm-hmm.
Do you expect to see more of that in like the USA's NAPAC and those kinds of contracts to have similar language in the near future?
Define near future?
Next 10 years?
Maybe.
Maybe. See the model takes precedence over
We are
contract documents.
We are talking about it internally. We have not executed any pilot project. The kind of sequence of events is we're definitely not going to go straight to issuing it out for bid. Like Sean has been engaged with our USACE Industry BIM Consortia where we vet through, is that feasible? What are the issues? So that's a process, and we've barely started talking about that in that group, but it's hugely important.
All right. Thank you, Van.
No, thank you.